Okay. So in the last session, okay, data integrity. So we said here to maintain accurate and consistency data into your database tables. Okay. And so what we said, guys, here, this integrity mechanisms, again, the two ways it was classified here. The first one we called as your declarative data integrity mechanism. First one we called as what now? Declarative. So declarative data integrity. And this is one thing here. And this integrity, if I want to implement here, so I can use one topic here by using of one of my topic is called as what now? Constraint. And constraint is one of the topic of in SQL language. And the second one is called as your procedural integrity. So procedural data integrity. So this integrity, do you want to implement here? So I'm using now. So one of the topic is called as what now? Triggers. And the triggers is one of the topic of PLSQL. So there are two kind of the methods and mechanisms are there to maintain accurate and consistency of data in your database tables. Okay, now so one is constraints and one more is what now? Triggers. Okay, right. So declarative data integrity, it can be implemented by using of constraints here, and constraint is one of the part of SQL. And procedural integrity, this is also used for to maintain accurate and consistency of data, but this can be implemented by using of triggers. But this triggers is not a part of SQL, is a part of PLSQL. So what is trigger advantages, how to prepare, what kind of benefits, purpose, okay, that all we discuss in the second part, PLSQL levels, okay. But now here we want to discuss, the first one is what now? Declarative data integrity. So declarative data integrity is also called as, it is a predefined integrity mechanism is also we called. Okay. So it also called as it also called as predefined data integrity we also called. So why we called it is a predefined means these integrity mechanisms whenever you want to implement, okay, we are using what now? Some predefined keys I'm using. With the help of those keys, okay, I can implement this mechanism here. So that's why it is also called as a predefined data integrity. We can also call. And this integrity mechanism to implementation, okay, okay, to implement, okay, to implement declarative integrity mechanism, declarative integrity mechanism, okay, mechanism, okay, we need to use what we want to use here, constraints. We want to use constraint. And this declarative, again, three types it will be classified here. First one is called as now entity integrity, okay, is my first thing, entity integrity. And second one is called as here referential integrity, referential integrity. And the third one is called as here domain, okay, domain integrity, domain integrity. Okay. So let me check it out. First of all, what is entity, referential, and domain? Okay, no. Let me come out and see. Entity integrity is nothing but, for example, your entity is nothing but table. Okay. So whatever the table are you prepared now? Suppose I'm going to prepare here table and a few columns we need to design. Okay. X column, Y column, suppose Z. So after designing your table with some columns, okay, then what we want to do, I need to insert some data into this table. For example, I'm inserting 1, some A, and some X. It's a one row. Second row, I'm inserting it 2, it's B, and Y. It's second row. And the third row, I'm inserting 3, okay, C, and Z. So whenever you will be maintain your data 1, 2, 3, that means it's called as a uniqueness. Do you have any duplicates in this? No. So each and every row, that means your row number 1, row number 2, and row number 3. So each and every row, if you see row values, every row is going to be identified with the unique number or unique data. When your tables will be maintained like this, each and every row will be identified with uniqueness. Okay. This kind of maintenance is called as a entity integrity, we called. So entity integrity is nothing but what now? In your table, entity is nothing but table. In your table, each and every row should identified with a unique number or unique value. So that kind of maintenance is called as a entity. For example, let me see. Suppose here the third row, are you inserted now to C, Z? I'm inserting now. Now in this case, what it was happened, this is my first row, second row, and third row. But in this, one of the column is called a X column. In this X column, can you see 2 duplicates are there? Yes or no? Yes. So that means row number 2, row number 3, the both are showing same number in your X column. So if any row will be identified with the duplicate values, then this table will not comes under entity relations. That's called entity integrity mechanism. It was not satisfied. So entity integrity rule, what it was telling this rule, each and every row should identify with the uniqueness. That means unique values, no duplicates. In that way, if you maintain your data, then we called as entity table or entity integrity mechanism is satisfied, I can say now. But if it was there like this, I cannot. But there is a chances to have a duplicate data, because yesterday I show you. So duplicate data we inserted, yes or no? Duplicates are inserted, nulls are inserted, and invalid data 36,000 years is also allowed. So if you are not applying any restrictions on the table, then there is a chances to occur duplicates. So that's why to overcome this, what do you want to do? Any one of column you have to take as a reference column. On that column, you can apply either primary key or else unique constraint should be applied. So these are the keys. These 2 keys, I'm going to applying of any one column. But these 2 constraint keys, on which column you applied in the table, that column is representing what now? Key column. It representing what now? Key column. Key column means main column. It's a main column. So it was saying that key column. So now in that key column, each and every row should identify with the uniqueness. Okay, now, but you are having a duplicate. But the advantage of primary key unique constant is what now? Duplicates are not allowed. Okay, now so that means if user you want to insert some duplicate data, either intentionally if you want to insert, but the duplicate data will never allowed. So duplicates are not allowed, but when I inserted here unique data, then it is allowed. Either primary key or unique, both are avoiding duplicates, and accepting uniqueness of data will accept it. So that's what happened. You can insert next row. If I insert next row 1, not allowed, 2, not allowed, 3, not allowed, then 4, allowed, because 4 is not a duplicates. So it will be allowed to you. So that means what you understand, entity integrity is nothing but it will be ensured that each and every row should uniquely identified in a table is known as entity integrity. And this entity integrity mechanism to implementation purpose, the users or programmers, they're using what now? Two kind of constant keys are using. One is primary key or else unique constant. So with the help of these two constant keys, I can implement my entity mechanism. Understand na? Right down below. Entity. It ensure that each row is identified with unique number in a table. Okay, how I can implement means so by using primary key, okay, comma, by using primary key, comma, unique key, constant can implement entity integrity. Okay, right. Second one is called as what now? Referential integrity mechanism. So this referential integrity is nothing but what now? Okay, to making relationships in between tables. Okay, so what it was say? To make a relationship, in between tables. Okay, so whenever you want to make it some relationships between the tables, so there you can use what now? Referential integrity now. And it can be implemented it can be implemented by using foreign key constraint. By using foreign key. And here foreign key is also called as a references key. is called as a references key. And the relations, how to make it, that I will explain in the example. Okay. Next. Third one is called as a domain integrity. So your domain is nothing but what now? Columns. Okay. Every column in a table is called as what now? Domain. Every column is called as what now? Domain. So this domain, how it was means, for example, in yesterday table, we created one column is called as a age column. So on this age column, if I'm not giving any restrictions or any rule is not applied here, then this age column will accept it 0, will accept it 10, will accept it 10, okay, 1, 10, and will accept it even though 36,000 also allowed. But 36,000 is right or wrong? Wrong. It's a invalid of data. But invalid of data is also allowed. So that means wrong data, when user inserted, the wrong data is also saved into our database tables. So this is what the problem here. So to overcome this, what I want to do on this column, suppose I'm applying some restriction. What is my restriction here? Check age between, okay, 1 and 100, if I'm giving now. So this kind of some condition was applied on the age column. Now tell me, your age starts from 1. So 1 is allowed, 2 is allowed, 3 is allowed, 10, 20, 30, 40, 50, 60, 70, up to 100. So that means 100 above age people cannot save here. Less than 1 year baby will not save here. So less than 1 year and above 100 years. So who are there like this? Those ages or those ages are not allowed. So your age is allowed from 1 to 100. So if that kind of restriction, if I'm giving now, so what is advantage to me? Unnecessary, invalid of data is not possible to insert. So in that cases, can I insert 36,000? No, impossible. So we cannot insert 36,000 years of age. So this kind of restrictions, conditions, validations I can apply by using of what now? Domain integrity. Domain integrity. Okay, na? Right down below. Domain integrity. To check values with user-defined conditions. With user-defined condition before allowed into a column in a table. Next point. So it can be used or it can be implemented by using check not null default constraints. Okay. So finally, these integrity rules, sir, if you need to implement practically on your table structures, so you require the knowledge of primary key unique constraint and foreign key constraint check, not null, and default. And these are all are what, sir? Means that these are all are called as a constants keys we called. What we called a constants keys. So now you can take now constants. The basically constants main intention to apply these constant keys on your table means what is the main intention here? To maintain what? Accurate and consistency data. That is the main cause of this. Okay. So that means what I say, constants are used to restricted or enforced unwanted data from a table. Okay, right. And these are constants keys. The total, how many are there? You can see. The first one we can go for unique. Second one we have here not null. The third one we called as check. Fourth one we called as primary key. So default. So these are total 6 constants are there here. Okay, now right. These are total 6, and let me see how these constants one by one we want to apply on your table at the time of creation or else after table creation. Okay, in 2 levels you can apply your constant. Okay, now right. But these constants, when you want to define or apply on your table columns, okay. So how many methods are there to applying my constraints on table columns? Okay, no? So there are 2 methods are there. Okay, no? So now below write down. All databases are supporting to define a constraint on a column in 2 levels. In 2 levels. First one we called as here. What is my first one here? Means column level constants. Column level constants. So what is the mean by column level constraints? Means here each and every column, when you want to create or define, after every column definition, immediately you have to pass your constraint name. Okay, now? So after your column definition is over, column definition is what now? Column name, data type, size. So this column definition is completed, then immediately have to apply constraint name. So that means here on each and every individual columns, we applied a constraint. That is called as what now? Column level constants we called. Okay, now? Now below right now. To define a constraint, on each column, wise. Each column wise. And now what is the syntax for this? Here observe. My syntax was, so create table name of a column names I want to give. Carefully observe here. Table name of a column name. Column name 1 and should give it a data type. And if it is size required, size. Next, comma, immediately have to take column number 2. And it was taking what now? Data type of a size, comma, and so on. Sorry guys, here after size, then you have to give constraint type. Constraint type, comma, then you can keep it here and give it your constraint type. Okay, comma. So, and so on. And so on. Column name n, data type, size, and you have to send your constraint type. Then close and close it. So n number of columns you can design, but every column definition after compulsory constraint name should be given it. Which constraint you want to apply. Okay, right. This is column level. So to define a constraint on each column wise, can you understand now? Suppose your first column constraint type, second column constraint type. Like you can say column number n, data type size constraint type. Okay, every individual column you can apply. Second one is called as what now? Table level constraints. Table level constraint. So table level means what it was happening, guys. Here we are defining constraint after all columns are declared. Okay, now. So once you declared your all columns, after declaration of all columns, then end of the table you have to apply constraint now. Okay, now. So write down below. To define a constraint, after declaring all columns in a table definition, okay, it means what, sir? It means end of the table. end of the table. Okay, now the syntax of this you can write now. So what is my syntax for this? So first you have to create your table. So to how many columns you want it, that every column should be defined. So column name 1 should use data type and use what now? Size, comma. Second one, column name 2, use your data type and size, comma, and so on, comma. So here you want to apply constraint type. Constraint type of, then you have to send column name 1, column name 2, and so on. Okay, so here differences carefully observed. Okay, right. So these are what now? Your column and table, and column level syntax, table level syntax carefully observed. Column level, each and every column definition after immediately we are applying constant name or type. That is column level, every individual columns. Table level means what now? First you need to define your all columns, and end of the table, end of your table definition, you can apply constant type, and after this constant are you applied on which columns, that column names are, you just pass it. Understand now? These are two different syntaxes, table level as well as column level. Okay, let me see one by one. We can check how to use these two levels. Okay, we will see it. The first constraint take. What is the first one? Unique. Now write down below. Unique constraint. So this unique constraint we are going to be using, guys, here. Okay, what is the purpose of this constraint means? It will be restricted. Okay, to restricted duplicate values, but allowed nulls into a column. Okay, now this is unique. So come to and see examples. First, I will show you column level example. Okay, now, so come out and see your database now. So my DB2 PM. Okay, now. So first I want to check my list of tables. So some tables I'm dropping now. Okay, fine. So come to your first column level I'm showing now. So my example of the table. So create table. Test one. Serial number integer. Serial number is my column name in this data type. After immediately I'm going to apply unique. That's called constraint type. Next I will take some name and it is varchar 2. There also I applied a unique constraint. So now you can see now how many unique constraints I was applied on this table? 2. One constraint we applied on serial number, one constraint we applied on name. So that means here 2 unique constraints we applied on 2 different columns. Yes or no? So this is this kind of definition. This is called as what now? Column level constraint we called. This is called as what? Column level constraint, because after every column immediately we are applying constraint type. Clear? So once you apply like this, what it was happening, suppose you applied a serial number, okay, column. You applied serial number column. On serial number column, you applied a unique constraint. So that means this column will not allow the duplicates. If you inserted 1, allowed. 2, allowed. But 2, not allowed. Because unique constant is there. But the problem of unique constant is what now? Not allowed duplicates, but allowed what now? Nulls. So nulls are allowed. Again, one more null if you insert, it is allowed. Nulls are allowed. Okay, same as. On the name also, you applied a constraint. Which constraint? Unique. So here also A allowed, B allowed, A not allowed. But null allowed. Okay, now so that means individually those columns will be checking whether it is duplicate or not. If it is duplicate, not allowed. If it is not a duplicate, allowed. That means individually every column their own it will be checking. This is column level constraint advantage. Okay, now let me see here. Okay, fine. I just go to execute. My table is created. Insert into test one, sending values of 1 comma a. This is first one. So for my first row successfully inserted, nothing problem. But in the second case, if I'm using 1 comma b, can I? No. Why, sir? Because the reason is what now? Already 1 is existing in my serial number column. And again, you are inserting same 1. Okay, now? Then it is called as what? Duplicate. Then it's called as a duplicates. So now see, it is not allowed. And saying what now? Unique constraint is violated. And in this violations, can you see here some number is there? So MyDB 2PM database sys underscore C007935. Some number is there. So what is this number and what it was represent? Represent means this is called as a constraint key identities we called. Like each and every constraint wise, internally system is created one identity. And this identity will be unique identity. Understand now? So what is this? What purpose it was created, sir? What is the use of this? That all I will explain to you in in coming classes. Okay, future classes, we will see that. But here up to now, what you understand, each and every constraint wise, one key identity was generated by your system. Okay, now that just keep it that. Later I will explain what is the use and advantage. Okay, right. So it is not allowed. Same as, let me come to A. Can I? No. Here also not allowed. So now we see again unique constraint is violated, and this is so and so number. Can you find out this number and this number? Change that was 35. This was 36. So uniqueness. 2 unique constraints, 2 unique ID numbers generated. So finally, the both columns are not allowed duplicates. Yes or no? Now, that's okay. Now I'm using to be allowed. And now you can see your table. But the problem is what now? Null comma null if I'm using. What happened? Allowed. One more time. Allowed. Okay, na? Null is nothing but empty. So any number of empty blocks you can create. Okay, that was allowed by your unique constraint. Okay. This is your column level, right? Completed. The next in this case, let me see table level. Okay. Right. So table level means what I said, after all columns definitions are declared, then end of the table you need to apply constraint. But the mechanism is very quite different. Carefully observe. Okay, no? Don't confuse. Observe. Same thing. Okay. I'm going to again. I'm creating one more table. So first you have to define your columns. After columns definitions are over, then apply unique on your column serial number and name. Now see here, first column, second column. My end of the table, I was used what now? Unique. And this unique constraint, I was applied on how many columns? 2 columns. So in this entire the table, how many number of unique constraints are there? Only one. One unique constraint I was applied on how many columns? 2 columns. So now you can see what it was happening. So when you apply your unique constraint on 2 columns, how it will be verify your data means your data will be verified here, combination of columns. Combination of columns. So here in the first case, individual columns are verified. Okay, serial number separately verified, name separately verified. But here when you come to here, it's not verified individually. Individually, it is not checked. The checking data with the combination. Okay, carefully observe. Suppose are you inserted? One comma A. It's my first record, allowed, nothing problem. And when I want to commit here, allowed. But the same thing, can you see? I'm inserting one more time. Can I allow this? No. And here, why it is not allowed this one more time means this combination already existing in my table. Combination already, this combination is already existing in my table. So again, the same combination I am inserting into the table, then it is called as what now? Duplicate combination. That's why it doesn't allowed. So it was showing that it is a duplicate. So unique constraint is violated, and this is your so-and-so number. But the same thing, if I want to write 1 comma B, allowed? Allowed or not allowed? So it is allowed. Okay, right. So now why it was allowed here, you can see. What I'm saying here, table level constraint, whatever you applied, that was checking a combination. Individually not check. It was checking like a pair, combination checking. So my first combination of data, 1 comma A. Second combination, 1 comma B. Both are different combinations. So that's why it's called a unique. Okay, different combinations called a unique is allowed. But again, now I can enter 1 comma B. Can I? Allowed? Why? Same combination already existing in my table. It's showing error. But now, allowed? Because this combination is not there. Not there means it is a new combination. It is allowed. Next. Allowed? Not allowed. Allowed? Next. Allowed? Next. Allowed? Next. Not. So understand now? In this my table, do you have any same combination? Having any same combination? No. Every combination is different. For example, nowadays cricket matches are there. Can I say like this here? India versus Australia. India versus Pakistan. India versus South Africa. Can India play with 3 different countries? Is it right? One team, one country can play 3 different countries. Possible? Not possible. Possible? Huh? So India versus Australia, 1 match. India versus Pakistan, 1 match. India versus South Africa, 1 match. So now I'm asking, do you have any repeated combination of teams having here? No. That means, can I say every combination of match is a unique match? Is it? Unique or duplicate? Unique match. India, Australia, unique match. India, Pakistan, unique match. India, South Africa, unique match. So there is no duplicates, huh? Is there any repetition match? No. But if I'm going to say, this is what? First match or second match? Second match. So this combination already played. Now again same combination of teams are playing. Then this is a first matcher, or we called as a second matcher. Second match. This is not a first match now. So how you can say a country can play with multiple countries? Okay, same as one with combination of A, B, C. All combinations are different now? Yes. Like how we can say 2, 2C, 2B, 2A. These are also different. Like even those, I can say like this, A1, A2, A3. Can I say? Yes. Okay, na? So this kind of combination of data verification is called as what now? Composite unique constraint we call, and every table level constraints are we called as a composite constraints. Okay, na? Mm. So below write down. Ah, okay. And here you just comment, gave it. So whatever you applied here. Okay. So whenever you want to apply like this, and that kind of constraints are called as composite constraint. Okay, now, right. This is unique cons. Okay. Now, next one right here, not null. So, not null, what it was do to restricted nulls, but allowed what now? Duplicate values into your column. And this not null constraint, okay, it can be defined, at column level only. Okay, so that means it doesn't support to defined at a table level. Column level, but not a table level. Okay, so that means your not null constraint is not supported table levels, only column level only supported. So now we can take example of column level. So come out and see your table. So create table test number 3 and see I was applied this. Okay. So this is, you know, that this is called as what now? Column level individually we applied. So table is created. One comma a, same one comma a will be allowed. And let me see, duplicates are allowed, huh? Yes or no? Yes. And now if I want to go for nulls, if I send it null comma b, if I send it, it was showing error on serial number. So serial number is not allowed because null. Same as now 2 comma null, if I inserted, it is also not allowed. Now the problem is a name column. Same as if you send the both levels, even though it's not allowed. So duplicates are allowed, but nulls are not allowed. Okay, right. Okay. Suppose a table level, if you want to see, observe, if I want to create my one more, that's number 4. Let me see your table level. Suppose you try to create it now. Varchar 2 of here. And end of the table, I'm applying what now? Not null on serial. Okay. Now here also I try to use my not null on multiple columns. Let me see to execute now. It was showing error, and what it was saying? Invalid identifier. So that means what you understand? Not null cannot be applied on a table level. It can be only for column level. Okay, now. So this is what now? Unique and not null. I stop it, guys, today. We'll continue tomorrow. Okay, now.